Hello everyone. Now in this video we are going to discuss question number 40 of GATE DA24 exam. Okay. Now this question is based on binary search algorithm. Let's solve this question now. We already discussed what is binary search in our course, so you can just go through that first, then you can solve this type of question. Okay. Let f of n denote the maximum number of comparisons made while searching for the entry in a sorted array of size n using binary search. Then which one of the following option is true? So here we are interested in the binary search and in maximum number of comparisons, right? For example, I have one array, for example 8. It's a sorted array, and let's say the size of this particular array be 5, n equals to 5. I have 5 elements in this particular array: 4, 6, 8, 11 and 13. Okay. For example, I have this 5 element having index position 0, 1, 2, 3, 4. Now what I need to do, I need to find out the maximum number of comparisons. So when this maximum number of comparisons will happen, when I want to search for the last element, that is this one. Okay. Whenever I want to search for the last element, in that case only I will require maximum number of comparisons. Okay. So if I want to search for 13, then only I will get the maximum number of comparisons. So let's say in our case, we have a key element that is basically targeted value as 13. Okay. So we want to find out this 13 into a array by using a binary search. How this binary search works? For example, this is my left hand, this is my right hand. Okay. Now how this binary search works? First we find out the middle position and we compare the element at middle position with the targeted or key value. So here how to find out the middle position? Simple. Mid equals to left plus right. So left plus right divided by 2. So 0 plus 4 divided by 2 is basically what? 2 here. So here we need to take the floor value. So if you see here, this particular symbol indicates the floor function, that is floor value we need to take, and this thing is basically what? Ceiling value. Okay, ceiling value. Okay. Now here the middle element. Now here the middle position is 2. That is basically this one. Now we need to compare the element at middle position. So a of 2 is basically what? 8. I need to compare with 13. So that is basically required key or targeted value. Now this particular 8 is less than my key value. It means I need to search on the right hand side of this particular middle element, because this array is already sorted, right, in increasing order. I know that this particular key is greater than 8. It means I need to search on the right hand side only. I don't need to search for the left hand side, right? Now in this case what will happen? This particular left will get updated to what? So left, or that is basically L, will get updated to mid plus 1, because I know I want to search on the right hand side. If my targeted value, for example key, is 4 and this 4 is less than 8, the middle value, then in that case I need to search on the left hand side. But our targeted value is 13, so we need to search on the right hand side. So that's why my updated left value will be mid plus 1. So here mid plus 1 is what? 3. So this will be my left and this will be my right now. Now again I need to calculate the middle element here. Again L plus R divided by 2. So 3 plus 4 divided by 2, that is basically your what? 3.5. So floor value of 3.5 is basically 3. Okay. Now again compare the third element of an array, that is basically 11, with the key, whether it's equals to my target value or not, or key value or not. No, it is not. So this particular value is less than my key value. It means that I need to search on the right hand side of this particular element, right? So again my left will get updated to what? L equals to mid plus 1. So mid plus 1 is what? The value of mid is 3 now. So 3 plus 1 is what? 4. Again calculate the mid value, that is L plus R divided by 2. So 4 plus 4 divided by 2 is basically a 4, right? So ceiling value is, so floor value is also 4. Now again, what is the element at index position 4? That is basically a 13. Now which is equals to my key value. Now here I found the my targeted value. Okay, so here my search gets complete because I got my targeted value or key value. Now, how many comparisons we have required? How many comparisons we have done to find out this particular value? So we are interested in maximum number of comparisons. So that's why we have gone for this particular last element. Okay. Now if you observe, here we have done first one comparison, here second comparison, and here the third comparisons. So we require three comparisons here. And how many elements we have? We have 5 elements, right? So when n equals to 5, my comparisons will be 3, right? Now just see which options is suitable here. Okay. So f of this floor value n by 2 plus 1. So floor value of n by 2, that is basically 5 by 2 is what? 2.5. So floor value of 2.5 is 2 and 2 plus 1 is what? 3. Yes, so this option satisfied. So option A is the correct one here. But what about the option B? Here again n by 2, our floor value is 2 plus n by 2 ceiling value will be what? 3, that is basically 5. No, it is not correct. I don't require a 5 comparisons here, right? What about C? It is again only a floor value, that is basically a 2. No, it is not correct because we required 3 comparisons. And what about D? So f of n minus 1, right? So what is n minus 1 here? That is basically a 4. Comparisons f 4 plus 1. No, that is not a correct one. Okay. Now, in this case, option A is a correct one because we only required 3 comparisons for n equals to 5 because we are interested in finding out the maximum number of comparisons. Okay. And this f of n will denote the maximum number of comparisons made while searching an entry. Okay. So same thing, f of this floor value of n by 2 plus 1 is required. Okay. So this is the correct option here. And please take a note that here it is f of n by 2, not n by 2, right? It's a function of ceiling, it's a function of floor value of n by 2. So what does this mean? It means that for every comparison, we are comparing n by 2 elements only, right? For the first comparison, we have compared only n by 2. Same thing, right? So we are comparing n by 2 comparisons only, and then at the last we have plus 1 because we finally got that particular targeted value is equals to our that particular element, right? So that's why it is f of floor value of n by 2 because in every search we are just reducing the size by n by 2, right? So that's why this particular option, that is f of floor value of n by 2 is there, right? Plus 1. So this is correct, right? I hope you understand this particular question. So that's it from this particular video. Thank you.